Hello, Worthington High School students. I'm talking to you, particularly you juniors. We're looking at our MCA test this spring, here in about a couple of months from now, and we're going to try to help you get prepared for that. I'm going to be going through several things that deal with algebra that could be on that state exam. So we're going to first of all start here today with what it takes to be a line and what a linear equation looks like. And if you remember, how many points does it take to actually create a line in space? And the answer to that is 2 points. So we got to remember 2 points will get us a line, and if you have that much information, a couple of points of information, you can in fact draw a line, and you can also get the equation for the line. So how does that work? Well, let's take an example of that. Here I've got a problem that says after 2 months of saving, Jimmy has $12 in his piggy bank. We're assuming Jimmy's a young guy. After 6 months, he has 36. Assume a linear relationship exists between the variables and write an equation. So this is the kind of a problem you could see on the MCA graduation part of that test. So I'm actually given 2 points of information. One of the things I always ask my class is what leads to what? Does money lead to months, or does months saved lead to money? And I'm hoping you guys would say that months saved leads to money. And then I've got 2 points of information. So essentially, if I was going to make a graph of this, the months lead to the dollars of savings. And essentially, I'm giving you 2 points of information. 2 months in, he's got so much money. And check back a little later, 6 months in, and he's got a fair amount of more money. Now, this is going to make a line, and lines have equations. So that the challenge here is to make an equation for that line. Okay? So to do that, we've got to remember a couple things about lines. First of all, lines have a slant to them. And how they're slanting can kind of tell you a number of things about them. First of all, this is slanting upward, which means we are accumulating more money, more dollars, as the months go up. So that is called the slope of the line. Okay, the slope is how steep it is going, the amount of change in the variables as they go. So that's what we have. Now, to figure out slope, there's a formula for that. We talk about how much change there is vertically, which we call the rise, to how much change there is horizontally, which we call the run. Essentially, it's the change in each of the variables. So there's a formula for that, and we let m be slope, and it is the difference of the y-coordinates, y2 minus y1, divided by the difference in the x-coordinates, x2 minus x1. So if you have a couple of points of information, you can actually put them into the slope formula and get the slope. So let's look at our points here. Our first point of information here is right here. 2 months leads to $12. So I'm going to put a 2, 12. 2 months, $12. The second point of information, 6 months leads to $36. Okay? I'm going to have to find the slope to plug into an equation model. Okay, now what I'm going to do is I'm going to scroll down a little bit and show you guys, or try to remind you of the different linear equation models you can plug into. They will have these on the state test. Okay? There's a model called point slope. This is a great model if you have a point of information and the slope. Okay, and that model says y minus the y-coordinate of a given point equals the slope m times x minus the x-coordinate of a given point. That's a very easy model to plug into because it says any point, any x1, y1 point, plus knowledge of the slope can get me a line which can lead to the equation. Okay? Now the second model that we use an awful lot in math is called slope-intercept. Now this model is a little bit prettier. It's y equals mx plus b. You will still see both models require you to figure out the slope of the line, or be given that. This one here requires knowledge of the y-intercept, which is the point where the function would start on the y-axis. Now we're not always privy to that information. So what we got to do is take what they give us and plug into the model that makes the most sense. Okay? And unless they give you as a starting point here, and they didn't. They said 2 months in we're here, 6 months in we're here. They just gave us 2 points. I'm going to go into the point slope model, probably. But you can actually do it in a slope int model as well, and I'll show you that also. You have to figure out the slope no matter what. So I'm going to do that. So m equals y2 minus y1. Now your first coordinate would be x1, y1, and your second coordinate would be x2, y2. So I'm going to put the values into the slope formula. So the difference of my y values, y2 is 36 minus 12. The difference of my x value is 6 minus 2, which I believe results in 24 over 4, or 6. Essentially what we're saying is his money, Jimmy's money, is going up $6 every month. That's his rate of change, or his slope. That's important. So I'm going to take one of these points, I'll take the one with the smaller numbers, and I'm going to use my point-slope form for a linear equation. So let's see if we can do that here together. So it's going to be y minus the y-coordinate of my point, would be y minus 12 equals the slope, which we just figured out is 6, times x minus the x-coordinate of my point. So it should look like that. Point slope is not a simplified linear equation form, so we got to do a little work here. Distributive property. So y minus 12 equals 6x minus 12. And then when you get y by itself, we actually are going to get our final equation. Y equals 6x. Okay? Now, I would remind you that y and x are actually standing for actual variables. Y is dollars and x is months. So at the end, it makes a lot of sense to change this to dollars equals 6 times months. Okay? So there would be a linear equation for this kid's savings, just given 2 points. If you want to use slope int, you can. You still have to get the slope. You still have to take a point. You put the y value in, you put the x value in, and you put the slope in because you're going to have to figure out what b is. So if I did that here, let's see, y is 12 equals the slope was 6 times x was 2 plus b. I'm going to get 12 equals 12 plus b. And when you subtract 12 or you just look at it, b is going to have to be 0. So what I really end up with is just y equals the slope 6 times x, and you get the same equation again. So it would be dollars equals 6 times months.